Hey guys, in this video we are going to understand that what is the basic difference between isobars, isotopes and isotones. Actually all of three are the terms from the chemistry basically, but they are also being used in various other fields like physics too. So it's very simple to understand it. Firstly, let's we understand that what's the meaning of iso. Iso means same. So if any word contains iso in its some portion, then definitely one thing will be same in that term. So according to a single alphabet from all these terms, we will be able to distinguish between all these terms. For example, first of all, in isotopes, the letter P over here, it will indicate the proton number. As you know that proton number is indicated by Z, but since P is indicating the proton, so that's why you can remember it, so that it will be easy for you. In the next term, isotone, the alphabet of N will help you to remember it, that N is indicating the number of neutrons that is being indicated by capital N. And lastly, the isobar, since capital A is the mass number, which is the sum of neutron number and the proton number or the atomic number. So A is indicating that the mass number in these kind of elements will be same. But the main difference between all these three terms is that the isotopes are of the single chemical element. You understand that? Mean, for example, you take the case of hydrogen, for example, then all these isotopes of hydrogen will be of different proton number, right? But of same proton number, right? But in the case of isotone and isobars, they will be of concerning the various elements from the periodic table, as we will see now in detail. Firstly, in the case of isotopes, you see here are some examples of the isotopes. For example, hydrogen, first of all, that 1 the smaller letter over here, that is actually indicating the number of protons, and this is the mass number. Okay, so it has one proton and one mass number. It means it has no neutron, mean number of neutron is 0 in this case. And in the second case, you see there is one neutron, definitely due to which it is indicated over here by H12. And in the case of tritium, it's 1 3, so there are 2 neutrons. Similarly, in the case of hydrogen, carbon, nitrogen, they are displayed over here. For more details, you can see that these are the hydrogen isotopes. That the first one, protium, has only one proton in the nucleus and one electron revolving around it, and there is no neutron. In the second case, deuterium, there is one neutron and one proton, and in the case of tritium, there are 2 neutron and 1 proton. So going back to the topic, the next term is the isobars. As I already told you that in these kind of chemical elements, the number of the mass number or the total mass of the element will remain same, and definitely it will be concerned to the various elements of the periodic table. So over here you can see there is a rule for the isobars that is stated over here, that if the two adjacent elements in the periodic table have isotopes with the same mass number, then they are isobars. You understand that? Mean in the periodic table, if you see that two elements that are just in with very close to each other, or residing just near to each other, then if both of them have isotopes which have the same mass numbers, then they are isobars of each other. For example, iron, this is the proton number and this is the mass number, right? So this is indicated as a series 58. So 58 means that 58 will remain as same. So in these two elements, mean nickel and iron, the mass number of both elements is same, so that's why it is considered as the series 58, and both are isobars, right? Similarly, the next examples are given over here, cesium, and for more understanding you can see this one. These are the isobars of each other, that they have different proton number and different neutron number, but when they sum up to each other, then the resultant is same. Mean in the case of calcium 40, in the case of krypton 40, and in the case of Ar, that's also 40. Now the last term was isotones, and these are the substances of the various elements which have same number of neutrons. So its examples are given over here. Just like isobars, this is series 20, so it means that number of neutrons in this series will remain as 20 and it will be fixed, not changeable. So for example, in the first case, as we were just discussing its example, that for example in this case 5 is the proton number and 12 is the mass number. In the next case 6 is the proton and 13 is the mass number, right? But what is the thing that is being changed, but even then in both cases that is same, that is definitely the neutron number, that is 7 in these both cases. Okay, so there are about even many series that are given over here, for which there are no stable isotones. Stable means that those isotones that can not radiate and can stay as they are actually. Otherwise, in the case of radioactive or the unstable isotones, they will keep decaying according to their half-life. Okay, so that was a basic difference. So if you are concerned with some kind of short question, that what is the basic difference between isotope, isotones and isobars, then that is given over here, that the isotopes are the atoms of the same chemical element, and isobars and isotones are the atoms which are concerned to the different chemical elements. Thank you very much for watching my video.